Thanks, everybody. I'm here to talk about Wi-Fi 7. I'm checking the clock, so I have 20 minutes. I'm here to talk about Wi-Fi 7, the latest generation of Wi-Fi. If you don't know who I am, my name is David Coleman. I'm with the Office of the CTO at Extreme Networks, where I function as Director of Wireless. If you're not linked up with me on LinkedIn, please do. So with that, I've been starting every presentation that I've been giving lately with this kind of catchphrase. And that catchphrase is that Wi-Fi is a way of life. And if you think about it, Wi-Fi, you use Wi-Fi from the moment you wake up in the morning. You have thermostats and doorbells that are using Wi-Fi. You go to breakfast, and at breakfast you start surfing the internet and checking the news. You drive to the coffee shop, you're at the hotspot, you're using Wi-Fi. Then you go to work, you're using your Wi-Fi as your primary access technology there. And then you go back home, and then you're using it again, and you also use it in play. Wi-Fi has been it's generational. As a matter of fact, if you're not aware, Wi-Fi has been with us now 25 years. The 25th anniversary of Wi-Fi was announced by the Wi-Fi Alliance. And that's phenomenal when you think about the technology. And it is, without a doubt, the primary wireless access technology that we use in our daily life and in the enterprise. Now, over the years, there's been numerous generations of Wi-Fi. And I'm not going to go through the whole, every generation. I just kind of want to point out here that recently, there's been, I can't get the spotlight to work, there we go. Recently, it seems like we've packed together 3 generations right within a couple of years. Because every 4 or 5 years, there's a new generation with new bells and whistles, new features, new speeds and feeds. But you notice in the last couple of years, we've had a couple stacked together, and really, Wi-Fi 6 now is 5 years old. And Wi-Fi 6E, all it was, is it introduced the era of 6 gigahertz connectivity. And it brought Wi-Fi 6 to the 6 gigahertz band. And I'm going to talk about Wi-Fi 7, which is now a thing. And there is now a Wi-Fi 7 certification that began in January of this year. But you should know, in my main view, even though I'm going to talk about some bells and whistles here, my main view is that Wi-Fi 7 is really going to be the next driver of the era of 6 gigahertz connectivity for Wi-Fi that is really, we're just at the cusp of. So with that, let's talk about some of the bells and whistles. So some of these features and capabilities are, I view as consumer grade, some are enterprise grade. And you are going to hear a lot of marketing about all of them from vendors and everybody else if you haven't already. So the one that you're already hearing about is 320 megahertz wide channels, which sounds great on marketing literature and a data sheet. You can modulate a lot of data on that, but right here in Europe and in the UK, currently that gives you 1 channel, okay? So great, that's fine and dandy, but even with 3 channels, like we can use in the United States, that does not scale in the enterprise. So this is a consumer grade feature. What worries me most about this feature in the enterprise is that you're probably in Europe going to be using a 40 megahertz design in 6 gigahertz. But if somebody brings in the consumer grade equipment nearby and they turn on a 160 megahertz channel or a 320 megahertz channel, that's going to absolutely cause OBSS interference, where primary channels and secondary channels are stepping on each other. And there's no way around this. So that's really the biggest worry. If somebody enables a 320 megahertz channel, it'll actually interfere with your enterprise design. I don't really have time to go into what OBSS interference is. I've written extensive blogs and spoken about it previously at other conventions, so I encourage you to read these blogs about it. But it is a potential issue if people are using these wide channels in the enterprise. It actually will be detrimental. The other feature that gets a lot of hype and marketing about speeds and feeds is 4K QAM. And 4K QAM is a new complex modulation technology that will give us a 20% performance boost. There's no doubt about it. The problem with 4K QAM is that it's going to require a pristine RF environment. You're talking an SNR of about 40 dB in most cases, or even higher. So it's not going to work in 2.4. It's going to be hard to achieve in 5 gigahertz. It'll work. Will it work? Sure, it'll work. It'll work at 6 gigahertz. I've already done some testing with it. This is a Wi-Fi 7 phone from a company called OnePlus. Excuse me, they're a Chinese company. And I did some testing, and you can see that MCS rate right there of about, 5764? Well, that actually requires the use of 4K QAM. Now, however, you need to understand that I was standing right next to the access point, within about 10 feet of the access point. So it will work, but will it scale out in great distances as it passes through the walls? The answer is no. So in my mind, it's really more of a consumer-grade feature. Now, what about Wi-Fi 7 for the enterprise? And let me back up just a second here. Before I talk about a feature that I think is a Wi-Fi 7 enterprise feature, Wi-Fi 7 is based on the 802.11be standard for extremely high throughput that promises data rates of 46 gigabits per second. Show of hands, how many people think we're going to have those data rates? Not one? Okay, not one brave soul. First of all, everybody knows that data rates aren't the same thing as TCP throughput, and we all know that the data rates are marketing, and if you turn on every single feature inside of a Faraday cage. Will we have data rates in 5, 6, 7 gigabits per second? The answer is yes, and in some cases, we might even see TCP throughput of about 5 gigabits per second. You'll see an example of that in just a second. So there is one feature that interests me for the enterprise, and that is multi-link operation. And we've never done this before in Wi-Fi. So think multiple channels and multiple bands, where a Wi-Fi 7 client could connect with a Wi-Fi 7 AP simultaneously on 6 gigahertz and 5 gigahertz at the same time. And this is new. Now, there's different kinds of MLO. The one that is going to get the most hype is the aggregation method, because it's going to advertise great promises of great speeds and feeds. So the thinking is, what if you could aggregate a certain amount of data modulated on an 80 megahertz channel on 6 gigahertz, and maybe a 40 megahertz channel on 5 gigahertz. And if you could send that data simultaneously, either uplink or downlink, the end result is that you get a data aggregate with ridiculously high data rates and much higher TCP throughput. Sounds wonderful, okay? Extremely high throughput. Now, that being said, it actually has a name. The technical term is simultaneous transmit receive multi-link multi-radio. Another acronym, okay? So here's the deal though. I don't anticipate this working on the client side with APs. And here's the reason why. And even the chipset vendors will tell you this. It's not going to be supported in any first couple of generations on this effectively. Is because medium contention. There's a very tight window right there where you have to link together and synchronize the aggregate. And we're talking microseconds here. And because of medium contention, you might grab that 6 gigahertz radio, you might grab that medium, but then you're still waiting for the 5 gigahertz medium to become available because it's much busier. And there's already been multiple studies that show that the actual wait time will actually cause throughput to go down. So don't have your high hopes for this for client to AP communications. However, it will work, and here's where it will work. AP to AP communications, mesh, okay? So if you could carve out a 5 gigahertz and a 6 gigahertz channel, or by the way, it doesn't have to be in different bands, it could be 2 6 gigahertz channels, or 2 5 gigahertz channels. And if you could carve out those channels out of your access plan and just have dedicate those strictly for what is called an MLO mesh, you can get some really, really incredible throughput. And I actually have some numbers to show you that. This comes from a friend of ours who works for a consumer grade company that makes these Wi-Fi routers that in pairs of 3 or 4 of them, and mesh is very important to them, and they've already got it working, and you can actually see the numbers right here. Obviously, it's under some controlled conditions, but you're seeing aggregate, and this is throughput, these aren't data rates, of throughput of over 5 gigabits per second. So that is a real use case, and I view that as a potential enterprise use case as well. Now, that being said, and this is what everybody laughs at me when I show the next slide, but that means that we finally need multi-gig. Okay, so 1 gig uplinks are not going to be enough finally, because it will be a bottleneck if you actually have a MLO mesh with TCP throughput of 5 gigs. So keep that in mind. Upgrading from multi-gig is a design and future-proofing need now. Now, there is another kind of MLO, and this is the one that'll work on client to AP communications. This is the steering. So imagine sending data back and forth between 6 and 5, whichever medium becomes available first. And the whole goal of this is to lower latency. It's to lower the latency. And with that, it actually has a name to Enhanced Multi-Link Single Radio Channel Access, EMLSR. And so think of on the client side, which most of them are 2 by 2. You're using one radio chain to listen on 5 gigahertz and another radio chain to listen on 6 gigahertz. And then whichever medium becomes first, you transmit with 2 by 2. First on 5, then on 6, then on 6, then on 5. And back and forth on maybe even a per packet basis. Okay? So, and this will improve latency. In my mind, latency is probably one of these metrics that as an industry moving forward, we're going to have to take a little bit more seriously for Wi-Fi. It's a metric where 5G is actually better at, private 5G, and it's a metric that's becoming more and more important. And this was designed specifically for applications like AR and VR, which we're just at the cusp of that technology finding its way into the enterprise as well. So we're going to probably in the future going to have to think about the latency as well as which also leads to the quality of experience metric more and more and more, not just in design but actual in real life scenarios as well. You can actually see there's a new information element that indicates what type of EMLO is being used. And I should have mentioned, once again, this will work right out of the bat with the client devices and APs. This now defines 2 MAC layers. These 2 MAC layers, there's an upper MAC and a lower MAC. Very simply, the upper MAC is for communications up the stack. And there has to be a representation of the MLO link. And what is in that upper MAC is a MLD MAC address. There's a MAC address. It's not the radio's MAC address. The radio's MAC addresses, are in that lower MAC. But the upper MAC contains this upper layer MAC address that basically represents the layer 2 connection of your MLO link. It is used to communicate upwards. And there will be an exchange where in management frames, where this information is shared between APs and clients. If you're using MLO and the capabilities, you will actually, during association, share your MLD addresses between the AP and the client, which is very important. And that is actually now the new seed for the 4-way handshake, which is kind of geeky, but why that's important is this new seed from the upper layer MAC is what is used to create your final encryption keys. And that way, you'll have one single PTK so you can switch back and forth between 5 and 6 gigahertz without having to do a new four-way handshake. So that's kind of neat. So quick question here. Before I get into the next topic, which is related to this, I think the big takeaway I want everybody to know here is there's these new bells and whistles with Wi-Fi 7, but really the main thing about Wi-Fi 7 is the continuation of the 6 gigahertz story, which is where I'm going to go to a little bit next. Let me ask a quick question. How many of you think you're going to turn on MLO right out of the bat? Yeah, okay, all right. Well, let me reword it a different way. Do you think Eka House should make a Sidekick 3 with a Wi-Fi 7 radio in it? Yeah. Putting them on the spot. My contention is immediately no, because quite frankly, we don't have a lot of data yet with what MLO is going to actually work in the field. So my guess is we have at least a couple of years of time to actually consume data and to see if there's even a need to even put like a Wi-Fi 7 radio in some of these predictive tools and troubleshooting tools. So I'll let you off the hook there. But at the end of the day is there's no way we're going to recommend turning on MLO right away in the enterprise until we learn a little bit more about it, until it's field tested. Wi-Fi 7 is a continuation of the 6 gigahertz story. And I'm going to bring this up even though you don't have this yet in the UK and in Europe. And that is, I do believe Wi-Fi 7 is going to drive the use of standard power. So this is imminent in the United States. We're finally going to get standard power, which will allow us to use external detachable antennas. It will allow us to use outdoor. By the way, standard power can also be used indoors. It gets a little trickier there. But this is going to happen like any moment now in the United States and in Canada. And we hope it will follow in the following years into Europe and the rest of the world as well. It does require AFC, where APs or an AP proxy, like the cloud or a controller, will send the geolocation of an AP up to an AFC provider, and then the AFC provider will then check against incumbent databases to make sure that your standard power AP is not interfering with any existing incumbents like fixed satellite services. And so this is coming. We're just waiting. It is incumbent on us as vendors to prove that we can accurately provide the geolocation coordinates to that AFC provider within 95% accuracy. And in America, we have to get what's called a PIA, a persistent approval for that. We're waiting for that from the FCC in the United States. As soon as we get that, we'll have a license, and then we'll be able to light up 6 gigahertz outdoors with standard power. The biggest issue you need to think about, though, with this is this, and I get asked this a lot. Well, will existing clients, 6E clients, be able to do standard power? And the answer is maybe. There's a different classification. It's called dual client. And all a dual client classification is it means that it can use either standard power or LPI power. Now, the good news is pretty much every device moving forward will probably be classified and certified as a dual client, so it'll have that capability, but that doesn't mean I can't promise that all the legacy 6E devices will have that. They can get recertified with something called a Class 2 permissive change, and then get recertified. It's a fairly easy process, and if they do that and then they update their firmware, then they'll be able to operate on either standard power or, standard power or LPI. It's not here yet. It's coming soon, hopefully to Europe. Look, we need what's called spectrum harmonization right now. There's a big effort for that right now going on in Europe. Right now, you only have 480 megahertz and only for LPI. We are hopeful. There's a lot of heavy lobbying going on, but it's very political to get all 1,200 megahertz of frequency space in Europe and the UK. So keep your fingers crossed for that. And if we get that, then I think the next step will be standard power. And I think Wi-Fi 7 will drive a lot of that as well. drive us towards standard power. And then the good news is you also will have the United States as a test bed for standard power where we can figure out if there's any problems before you test it here. So quickly, I know I'm running a little bit over. If I just give me 2 more minutes, I do want you to understand that there's some other things you need to think about with Wi-Fi 7. PoE is critical. The days of AF are over. You're going to need AT power, and if you're 4x4x4, you're going to need BT power. Otherwise, you're going to have APs randomly rebooting. And really, the last 2 slides I want to show you is I was talking about SSIDs, and I've been talking about that and the strategies for 6 gigahertz. And I'm confident now that you can use the same WPA3 enterprise SSID across all bands if you use the transition modes with WPA3 enterprise, for example, Eduroam. But think about MLO. Do you really, you're going to probably, when you decide to turn it on, you're probably going to want an entirely separate SSID. And they're talking about using transition modes. Do you really want your legacy clients connected to an MLO SSID at the same time? Probably not. So that's probably going to be the best practice moving forward. And so I've kind of run out of time. I just want to show one more slide, and that's this, because it was mentioned in a previous presentation that you guys did about range. And 6 gigahertz does have shorter effective range than 5 gigahertz. It's just due to free space path loss. There's that 2 dB difference. Really, the bigger thing is in the United States, the clients have to be 6 dB lower than the AP. Here's the good news about Europe. You don't have that problem. With Europe, the client and power can match the AP power. So the range conversation is not as critical here in Europe, in the UK, that it is in the United States due to that 6 dB difference. So keep that in mind. You are lucky in that regards. And with that, I just want to say once again, oops, I'm going the wrong direction. Once again, thank you very much. Wi-Fi 6E and Wi-Fi 7 are really a paradigm shift for us. 6 gigahertz is the future. Wi-Fi is a way of life, and thank you for my time.
Thank you.